Competitive shooting is a diverse sport with many disciplines and match formats. The sport relies on a combination of the quality of the firearm, the ammunition, and the skill of the marksman. Metrology, or the science of measurement, is an important part of competitive shooting. Ammunition quality is a key component of the overall performance of the shooting system. John Wooden, six-time national high-power rifle long-range champion, remarked, "Often matches can come down to the quality of ammunition." In the 2010 competition, Mr. Wooden received 1,243 points across 125 shots at a range of 1,000 yards. The second-place competitor received 1,240 points. With scores that close, just a few rounds that are not manufactured precisely can be the difference between winning and losing. Ammunition can be factory-loaded or hand-loaded. Depending on the goals, hand-loading, also referred to as reloading, can be used for cost savings and/or performance improvements. The process of reloading involves many steps. The most critical steps in terms of metrology are adding gunpowder and setting the seating depth. The gunpowder is weighed to ensure the desired amount is used. The length of the cartridge is measured to ensure the proper seating depth is reached. To illustrate the potential performance improvements between factory-loaded and hand-loaded ammunition, my dad and I tested 5-round groups of .308 ammunition. We compared factory-loaded rounds and hand-loaded ammunition with varying amounts of powder. The mean radius of the groups are used to compare the performance. The mean radius is calculated by locating the center of the group and determining the average distance of impact from the center. I used the Hornady Ballistics app to automatically calculate the mean radius. The factory-loaded ammunition was the least precise with a mean radius of 1.25 inches. The hand-loaded ammunition with 45.5 grains of powder had the lowest mean radius of 0.28 inches. All of the hand-loaded rounds had a tighter group than the factory-loaded rounds, demonstrating the effectiveness of careful manufacturing. The variation in velocity also matters, especially for long-range shooting of 300 plus yards. Variations in velocity changes the amount of time gravity and drag can affect the shot, causing it to drop different amounts. According to Mr. Witten, at 1,000 yards, a 50 feet per second change in velocity causes a 10-inch difference in impact location for the two shots. This takes away half of the 20-inch ring for maximum points, leaving very little room for other potential errors. The velocity of the shot is measured with a chronograph. For our test, the 44.5 grain rounds had the lowest velocity variation with an extreme spread or range of 22.3 feet per second and a standard deviation of 8.2 feet per second. The average velocity was 2,613 feet per second. If shooting distances further than the 100-yard test, more investigation into velocity variation would need to be conducted, as the tightest group did not align with the least velocity variation. Ensuring ammunition is manufactured precisely through metrology is an essential component of competitive shooting. Unsatisfactory ammunition can affect the outcome of competitions.